Hello everyone, welcome to today's lecture. So in the other lecture we started with chapter 12, reflection of sound, that is study of sound. Okay, now we studied about different terms like amplitude, wavelength, hope you have gone through it. Okay, and the different factors which affects the velocity of sound in gaseous medium. Then about audible range of sound, it is from 20 hertz to 20 kilohertz, and the uses of ultrasonic sound. Today we may move on to the next topic, that is reflection of sound. Just like we studied in reflection of light, reflection of sound also obeys the laws of reflection. That means the angle of incidence is equal to angle of reflection. To show that, there is an experiment shown there. There is a stopwatch which is kept. There is a bigger reflecting surface which is kept at one end, and there are two tubes. You have to keep the stopwatch at one end of one tube, and you have to hear that sound with the help of another tube. Okay, you have to move the tube forward and backward and hear the sound where you can get the maximum sound. You may see that you will get the sound when theta 1 is equal to theta 2. That means they have shown two angles there. Those two angles, when they are equal to each other, at that position you will be able to get the maximum sound. So that is about reflection of sound. Okay, so like light waves, sound waves also get reflected from a particular surface. Okay, now there are good and bad reflectors of sound. Okay, good reflectors of sound and bad reflectors of sound. It has been given in the last paragraph. A hard and flat surface is a good reflector, while clothes, paper, curtains, carpet, furniture, etc. are bad reflectors. They absorb sound and therefore they are called as bad reflectors. You may mark that this is asked as a 1 mark question. Give examples of bad reflectors of sound and give examples of good reflectors of sound. Now, page number 132. In the activity on page number 131, what will happen if you lift one of the tubes to some height? What will happen? The sound which you will be hearing will get reduced. That means it should be at the same plane. Now the next is, you have got two examples of reflection of sound. One is echo and other is reverberation. You might have heard about echo. Echo is a reflection of sound from a particular surface which is away from us. Okay, you might have tried to make echo when you go to hill stations. Okay, there is an echo point at every hill station. So echo, what is echo? You may underline the definition of echo. It is the repetition of original sound because of reflection by some surface. There is a surface which is far away, and from that surface the sound is getting reflected. Okay, this term original is very important. Okay, so the original sound is getting reflected once or twice or thrice. Okay, and we are able to hear the particular sound very clearly. Okay, we are able to make up that sound. Okay, make up that sound means we can understand in each and every echo what we had spoken. Okay, so that is echo. There is a minimum distance between the source and the reflecting surface. Source is the point from where the sound is getting produced, and the reflecting surface is the surface which is far away from where the sound is getting reflected. There is a particular condition which has to be kept in mind, then only you can produce an echo. Now here the position is distance. Given what has been considered, the sound should take more than 0.1 second. This we know. What do we mean by that? When I am talking, in between each and every swar, okay, in between each and every letter, there is distance of 0.1 seconds. That is why, more than 0.1 second maybe, that is why you are able to understand what I am speaking about. If my speed was very fast, if it was less than Okay, if it was less than 0.1 second, then you might not be able to understand what I am talking about. That means the sound should take more than 0.1 second to go and come. Okay, so the time is 0.1 second. The minimum time required is 0.1 second. Next, at 22 degrees Celsius, the velocity of sound is 344 meter per second. This has been calculated. Okay, so the sound which fall on the ear, okay, it should be having a distance of 0.1 second. Otherwise we won't be able to understand. We are able to hear the sound, but we won't be able to understand what the person is talking about. Okay, and the sound velocity of sound at 22 degrees Celsius is 344 meter per second. So we have the speed, we have the time, we have the velocity, we have the time. So velocity is 344 and time is 0.1. Here the speed and velocity, they are a common term which are used for you to understand. Okay, and now this will give you 34.4 meter. Okay, now this is the sound, it's the distance which the sound has to travel one way and two way. Okay, that means going and coming. So what will be one way distance? The one way distance will be half of this, that is 17.2 meter. So that means the minimum distance of the reflecting surface should be 17.2 meter. That means first of all, first condition is that you should be having a big reflecting surface. Second condition is that it should be kept at a minimum distance of 17.2 meters. Then only you will be able to hear an echo. Okay, so what is an echo? It is a repetition of original sound which you can understand. Okay, the complete statement is being repeated and you are able to hear the complete statement back. Okay, that is said to be an echo. Now the next is about reverberation. Now what is reverberation? Reverberation is a condition where there is reflection of sound, but we are not able to make up, we are not able to understand the particular statement which the person is talking about. For example, in some auditoriums or at some in some halls, you may see that when you talk there are multiple reflections. We call it as echo. In our normal language we call it as echo, but in physics it is not an echo, it is said to be reverberation. So reverberation is reflection of sound which take place multiple times and we are not able to understand what the person is talking about or what the particular sound is about. Okay, that is called as reverberation. And why does this occur? Because the time is smaller. The distance might be also smaller. The time is also smaller. Time is smaller means it is less than 0.1 seconds. Okay. Now we may see page number 132. The third paragraph is very important. That question, this derivation is a 3-mark question, a very frequently asked question. Okay. Next, compare the two cases. They have given two cases to explain about reverberation. Both are examples of reverberation. Page number 133, the first statement and the second statement, that is the definition of reverberation. Sound waves get reflected from the walls and roof of room some multiple times. This causes a single sound to be heard not once but continuously. This is called as reverberation. Okay, so what happens, the sound gets mixed up and we are not able to understand. You cannot decipher, it cannot be deciphered clearly. Deciphered means make out. Okay, to make it out. So what the person is talking about, we are not able to understand. That is due to reverberation. Now how can you reduce reverberation? Reverberation could be reduced by using bad reflectors in halls and auditoriums. In a particular place where there is reverberation, you can use bad reflectors like curtains, clothes, seat covers. Okay, you might have seen in theaters the seat covers are rough. Okay, they are having rough wall surfaces, rough roof surfaces. This is to prevent reverberation. Okay, now the next topic in your textbook is about sonar, which is an application of reflection of sound. Now what is sonar? Sonar is sound navigation and ranging. Sound navigation and ranging. Where is it used? It is basically used to determine the depth of the sea. There is a ship. The ship wants to determine how deep the water is. What is the depth of that particular point? That distance has to be measured. It is measured with the help of this device that is called as sonar. Okay, now what is done? Consider this as a ship and this is the water bed. Okay, so this is water. This is water. Now this is a place inside the ship from where a sound is transmitted to the bottom of the sea. Okay, it is transmitted to the bottom of the sea. It will go down, it will strike the surface of the seabed and it will come back. Okay, it will come back. So this is said to be the transmitted pulse, and the reflected one, it is said to be the reflected pulse. Okay, so the time from which it has been the time from the time where it has been transmitted to the time it has been received, that time taken is calculated. That means as soon as the pulse is transmitted, they put on the stopwatch. As soon as they get the reflected pulse, they put off the stopwatch. So we will get the time taken, and we know the velocity of sound in water. So we know the velocity, we know the time, you can calculate the distance. Okay, so this is how the sonar works in a ship. Now the uses of sonar, you may see page number 133. The first paragraph under sonar. It is used to determine the direction, distance and speed of an underwater object with the help of ultrasonic sound waves. Okay, that is the first use. The different uses are in the last paragraph. You may see sonar is used to determine the depth of the sea. Sonar is also used to search underwater hills, valleys, submarines, icebergs, sunken ships, etc. Okay, so the uses of sonar is very frequently asked, and the working. Once again, I will tell you the working. The pulse is transmitted into water, and the reflected pulse is received by the ship. The time taken for the pulse to go and come, that is calculated, that is measured, and with the help of that time and the velocity of sound in seawater, that with the help of these two values you can measure the distance of the object under the ship. Okay, how much distance there is the object or the seabed. So this is about sonar. Now the next is sonography. You may see on page number 134. You might have heard about sonography. Sonography is a technique which makes use of ultrasonic sound wave. These ultrasonic sound waves are produced by a particular probe, okay, a particular device. Those waves will go inside the body. It will strike the particular organ and come back. Okay, it will come back. The movement by which it is moving inside, it is getting reflected, that is studied and it is converted into images and it is observed on a monitor. You may see sonography technology uses ultrasound waves to generate images of internal organs of the body. The first paragraph is the use of sonography. It is very important. This is useful in finding out the cause of swelling, infection, pain, etc., the condition of the heart, the state of the heart after a heart attack, as well as the growth of fetus. Fetus means baby inside the womb of a pregnant woman are studied using this technique. Okay, this is the uses of sonography. Now next paragraph is the functioning, the working of sonographic device. Okay, sonography machine. You may see sonography machine is given in the diagram. In the middle they have shown the probe. Okay, this probe produces, this probe is kept on the body part. It will produce the ultrasonic sound waves, and it will go inside the body and come back. It is received by the probe itself, and it is converted into an image, and that image is shown on a monitor. Towards the right hand side you may see they have given an example of the image obtained. Okay, so this technique make use of a probe and a gel. The gel is used to make the proper contact between the skin and the probe so that full capacity of ultrasound can be utilized. There is a gel which is applied first. Okay, the gel is applied first and then the probe is moved over that gel. The gel is applied to the skin outside the internal organ to be studied. High frequency ultrasound is transmitted inside the body with the help of the probe. The sound reflected from the internal organ is again collected by the probe and fed to the computer, which generates images of the internal organ. As this method is painless, it is increasingly used as a medical practice. Okay. Now, always remember there is a box given. In that box, they have told about female infanticide. Okay. Now, feticide. Okay. Female feticide means the female fetus, the female baby. When a lady is becoming pregnant, when the sonography is conducted of that particular female, the doctor can understand whether the baby inside, whether the fetus inside is a boy or a girl. Okay, now in our society there are some people who don't wish to have a female child. So what they do, they kill the child, they abort the child. Okay, that is called as female feticide. The female child, if the person come to know that it is a female, it is killed. Now this is a misuse of sonography technique. Okay, so today we studied about good and bad reflectors of sound. Basically reflection of sound, the two types of reflection of sound, echo and reverberation, sonar and sonography. You may go through the textbook. If you are having any doubt, you may ask. Thank you.